The biology of sleep, every stage explained and why you cannot skip any of them. Have you ever wondered what your brain and body are really doing while you sleep? You may think sleep is simply a time when your body shuts down. But biologically, sleep is one of the most active and organized processes your body performs. While you're asleep, your brain changes its activity, your heart rate and breathing slow down, your muscles relax, hormones are released, memories are processed, and your body carries out important repair and maintenance. And here's the fascinating part. You don't experience just one type of sleep. Throughout the night, your brain moves through several distinct stages, and each stage has a different purpose. Today, we'll break down every major stage of sleep, what happens inside your brain and body, and why healthy sleep depends on moving through these stages in the right pattern. Let's start at the beginning. Stage 1. The transition into sleep. The first stage is called N1 sleep. N1 means non-rapid eye movement stage 1. This is the transition between being awake and being asleep. It's the lightest stage of sleep, and it usually lasts only a few minutes. Your brain activity begins to slow down. Your muscles start to relax. Your heartbeat and breathing gradually become slower and more regular. Your eyes may move slowly beneath your eyelids. Because you're only lightly asleep, you can usually be awakened quite easily. You may also experience a sudden muscle jerk or feel as though you're falling. This is called a hypnic jerk, and it's a common part of the transition into sleep. So, N1 is essentially the doorway into sleep, but your brain hasn't gone very deep yet. Next comes a much more stable stage. Stage 2. Stable sleep. Stage 2 is called into sleep, meaning non-rapid eye movement stage 2. This stage makes up a large portion of your total sleep. During N2, your body becomes more relaxed. Your heart rate slows. Your body temperature begins to decrease. Your breathing becomes more regular. And your brain produces distinctive patterns of electrical activity. Two important patterns are called sleep spindles and K-complexes. Your breathing becomes more regular, and your brain produces distinctive patterns of electrical activity. Two important patterns are called sleep spindles and K-complexes. Sleep spindles are short bursts of brain activity that are thought to play an important role in learning and memory. K-complexes are large brain wave patterns that may help your brain respond to important external information while allowing you to remain asleep. In other words, your brain isn't simply switched off. It's actively regulating what information deserves attention and what can be ignored. And sleep helps maintain stable sleep and prepares your brain and body for deeper sleep. And that's where things become even more interesting. Stage 3. Deep sleep. Stage 3 is called N3 sleep, also known as slow-wave sleep. N3 is the deepest stage of non-rapid eye movement sleep. During this stage, your brain produces very slow, high-amplitude electrical waves called delta waves. Your muscles are deeply relaxed. Your breathing and heart rate become slower. And you're much harder to wake. If someone wakes you during deep sleep, you may feel confused or disoriented for a short time. But why is deep sleep so important? Your breathing and heart rate become slower, and you're much harder to wake. If someone wakes you during deep sleep, you may feel confused or disoriented for a short time. But why is deep sleep so important? This is one of the major periods when your body carries out physical restoration and recovery. Growth hormone release increases during deep sleep. Your tissues undergo repair and maintenance. Your immune system is supported. And your brain also appears to use this period to help regulate and organize information accumulated during the day. Deep sleep is particularly important for physical recovery. And here's something interesting. Deep sleep tends to be more abundant earlier in the night. As the night progresses, the amount of N3 sleep usually decreases. But we're not finished. Because after moving through non-rapid eye movement sleep, your brain eventually enters one of the most fascinating states of all. REM sleep. The highly active brain REM stands for rapid eye movement. During REM sleep, your eyes move rapidly beneath your eyelids, while your brain becomes much more active. In some ways, brain activity during REM sleep can resemble wakefulness. This is also the stage strongly associated with vivid dreaming. But REM sleep isn't simply about dreams. Your brain is processing and reorganizing information. REM sleep appears to play an important role in learning, memory, emotional processing, and brain development. At the same time, most of your skeletal muscles become temporarily inhibited. This is called remitonia. It helps prevent you from physically acting out most of your dreams. Your breathing can also become more irregular, and your heart rate may vary. So while your body is relatively still, your brain can be highly active. And then something remarkable happens. You start the cycle all over again. The sleep cycle. A typical sleep cycle moves through N1, N2, N3, and REM sleep. One complete cycle generally lasts around 90 to 110 minutes, although the exact duration varies from person to person and from cycle to cycle. And you don't simply go through these stages once. During a normal night, you usually experience several cycles. Early in the night, you generally spend more time in deep N3 sleep. Later in the night, periods of REM sleep become longer. This changing pattern is called sleep architecture. During a normal night, you usually experience several cycles. Early in the night, you generally spend more time in deep N3 sleep. Later in the night, periods of REM sleep become longer. This changing pattern is called sleep architecture. Sleep architecture is the overall organization and sequence of your sleep stages throughout the night, and it explains why sleeping for only a few hours can be very different from getting a full night's sleep. If you cut your sleep short, you're not simply losing sleep time. You may also be reducing the amount of time your brain has to complete its normal sequence of sleep stages. Can you skip a sleep stage? So, can you actually skip one of these stages? Your brain doesn't normally choose to completely eliminate a stage during healthy sleep. You may also be reducing the amount of time your brain has to complete its normal sequence of sleep stages. Can you skip a sleep stage? So, can you actually skip one of these stages? Your brain doesn't normally choose to completely eliminate a stage during healthy sleep. Instead, the amount of time spent in each stage can change depending on factors such as age, sleep deprivation, stress, medications, illness, and your overall health. For example, after losing sleep, the brain may increase certain stages during recovery sleep. This is sometimes called sleep rebound. The important point is that healthy sleep isn't simply about being unconscious for a certain number of hours. It's about allowing your brain and body to move through their normal sleep architecture. Light sleep helps you transition into sleep and maintain it. The important point is that healthy sleep isn't simply about being unconscious for a certain number of hours. It's about allowing your brain and body to move through their normal sleep architecture. Light sleep helps you transition into sleep and maintain it. And to sleep supports stable sleep and important memory-related brain activity. Deep N3 sleep supports physical restoration and recovery. And REM sleep supports learning, memory, emotional processing, and other brain functions. Each stage contributes something different. What happens when sleep is consistently disrupted? Now imagine that your sleep is repeatedly interrupted. You may still spend 8 hours in bed, but if your sleep architecture is constantly disrupted, the quality of that sleep can suffer. You might wake up feeling unrefreshed. Each stage contributes something different. What happens when sleep is consistently disrupted? Now imagine that your sleep is repeatedly interrupted. You may still spend 8 hours in bed, but if your sleep architecture is constantly disrupted, the quality of that sleep can suffer. You might wake up feeling unrefreshed. Your concentration may decline. Your mood can become more unstable. And over time, chronic sleep disruption is associated with problems involving metabolic health, cardiovascular health, immune function, and cognitive performance. This is why sleep quality matters alongside sleep duration. It's not just about how long you sleep. It's also about how well your brain and body move through the different stages. The big takeaway: so, what should you remember? Sleep is not one single state. It's a carefully organized biological process. You move from light N1 sleep into N2, then deeper N3 sleep, and eventually into REM sleep. These stages repeat throughout the night, creating a dynamic pattern that changes from the beginning of the night to the end. And each stage has a purpose. N1 helps you transition into sleep. N2 stabilizes sleep and supports important brain processes. N3 provides deep restorative sleep. And REM sleep supports learning, memory, emotional processing, and brain function. So when you sleep tonight, remember this. Your body isn't simply resting. Your brain is working through a carefully coordinated biological program designed to help you recover, learn, adapt, and prepare for another day. Sleep isn't wasted time, it's active biology. If you enjoyed this video, subscribe to PharmaconHealth for more simple, science-based explanations of the human body, health, medicine, and wellness. PharmaconHealth, science meets self-care.